Well, now let's use sequences to prove the exact same thing. So that means theorem 2.1 is going to come into play. So using sequences, we'll just say that the sequence xn, let that sequence be such that xn converges to 0. So we don't know if xn is rational numbers or irrational numbers. Well, we know it's one or the other. Each term is either one or the other. And I guess technically by the definition, xn, each xn is supposed to be different from 0. So it's a sequence that has no terms equal to 0, but converges to 0. And let epsilon greater than 0 be given. What we're going to do this time is we will find a capital N in the natural numbers such that if n is greater than or equal to capital N, that means that the sequence f of xn minus the limit, which is 0, is less than epsilon. So this looks a little bit like the previous method already. Okay, we need to find that n. We didn't find it. I'm just using the definition there. So now let's choose capital N so that the following is true. N greater than or equal to n implies xn is less than 1 and x capital N is less than epsilon. So I could have done that in one statement by saying choose it so that xn is less than the smaller of 1 and epsilon, like we did in the previous proof. Maybe I'll go ahead and say that. Or x capital N less than the minimum of 1 and epsilon. So it looks just like the previous proof. Now, why do I know an n exists like that? And I could write it down as a statement because xn converges to 0. The sequence xn converges to 0, so I know this n exists. Therefore, our last line, n greater than or equal to capital N implies that f of xn, which is less than or equal to x squared, remember that from last time. I left off the absolute values because x squared is always a non-negative number. And that's less than x. I guess I should put less than absolute value of x. And that needs an n, and that needs an n. And that's less than epsilon. For the same reasoning as last time. This part is true because xn is between 1 and -1. Actually, it's strictly in between.